Welcome back, guys. It's Mrs. Webb here, and we're going to chat about average speed today. So, couple of definition kind of things here as we get into our physics unit, because it's a little, the way physics talks about averages is slightly different than the way you guys have been dealing with averages in math, where, you know, you sum up all of your volumes, for example, and divide by the number of volumes, right? Here, when we talk about average speed, it has a slightly different connotation. So we're going to define a couple of things here for you to start. You know, this first term, distance, is going to be nothing new to you guys, and we did chat a little bit about distance yesterday, or the last time in our intro to graphing lesson. And so distance in physics is given the variable lowercase d. And units that we can use, there's really a wide variety of units that we can use when we talk about distance. I suppose the most common would be meters or kilometers for what we're going to be doing. But you could even talk about light years as well. You know, if you were talking about something traveling through space, for example. And light years is 300 trillion miles, right? So quite a large distance. When we do talk about distance, specifically what we're referring to is what is the amount of space between point A and point B. And one thing that's important for you guys to note is that when we do talk about distance, distance is what we call a scalar quantity. And when we talk scalar quantity, what that means is that that particular distance will have a magnitude, for example, 35 kilometers, but it has no direction. So we're not specifying which direction that 35 kilometers went. So it's not 35 kilometers due north, for example. We're just saying, you know, a person traveled 35 kilometers. So that's an important term for you guys to know. The scalar term is important for you guys to know, because we're going to be doing a lot of work with scalars and vectors coming up in the next few lessons. So that's our first variable to talk about, is our distance. Scalar term, it'll have a magnitude, and it measures that spacing between point A and point B. In terms of time, time units are expressed in typically seconds, I suppose in the questions that we work on, but you'll see it in hours or minutes, right? And the important thing for you guys to remember is we still do a little bit of unit analysis here. Important thing for you guys to remember, and I don't think this is anything you have to, you know, work hard at remembering, there's 60 seconds in 1 minute. There's 60 minutes in 1 hour. And if you just want to jump from seconds to hours, there's 3,600 seconds in 1 hour. And when we talk about time, we're referring to that time increment, the rate at which the object is moving. So how long does it take that object to move? And again, time is a scalar quantity. Or sorry, it's not the rate. I jumped down to the next point. Sorry. It's that time interval between 2 points. How long does it take that object to move? The last one that we need to define for today is our speed. And our speed is a scalar quantity as well. This is the one that describes the rate. So, you know, that how fast is the object moving? What is the rate of motion for this particular object? And units for this, you know, it's always going to be a distance over a time. It could be centimeters per second, kilometers per hour, meters per second. Those are probably the most common ones that we'll work with. But thing to remember is that when we talk about speed, we're talking about a scalar quantity. So traveling, you know, 80 kilometers per hour, but we're not saying anything about where, in what direction we're moving. We're just saying that that's the particular rate of motion for that particular object. Okay. so those are the kind of the first three variables we're gonna talk about. There are a couple of types of speed that we're going to get into, and types of speed probably sounds a little strange, but when we talk about types of speed, we can talk about an object moving at what we call a uniform rate or uniform speed or uniform motion. And when we're talking about an object moving at uniform motion, you can kind of imagine that object being in cruise control. So you get on the highway, you get to 110 kilometers per hour, you hit the cruise control button, and you just coast for however long at that particular constant speed. That's what we call our uniform motion. We're going to do a lot of work with uniform motion. Instantaneous speed. Instantaneous speed is the speed or that rate of motion that the object has at an exact point in time. Okay, so, you know, at 8 seconds, the object was moving at 3 meters per second, right? So at instant, that's the speed that this particular object had. And a lot of times, when we do talk about instantaneous speeds, we're talking about, you know, maybe like a race car that's speeding up at that point. So they're actually accelerating when that's happening. And then the third term that we're going to talk about today is average speed. So we're going to pretty much for the next little bit, we're going to be talking about uniform motion, where objects are traveling at a uniform rate. But we're gonna do a bunch of calculations. So the very first calculation that we're gonna look at is calculating average speed. And the important thing to note with average speed is that average speed is that total distance that an object travels over that entire period of time. Okay? So the formula for this, and you guys will receive a formula sheet. The formula for this is V average is equal to delta D over delta T. Okay. And the important thing to note about delta D in this formula, because a lot of times when we have this delta, we refer to it as a change in distance, right? And we're used to doing like distance final minus distance initial, or time final minus time initial. In this case, and I'm going to change this up because it's not right. We're looking at the total distance traveled. So we're looking at, grab a pen here, distance 1 plus distance 2. Oh, why do we keep shifting over? Let's see if I can make this back over. So distance 1 plus distance 2 plus distance 3 plus, and on and on and on and on. That's specifically what we're looking for. This is the part I want to get rid of. When we're looking at total time, we're looking at time 1 plus time 2 plus time 3 plus, and on and on and on and on and on and on, right? So here we're looking at that sum of all of those little individual distances that you may have traveled on your trip, plus the total time that it took, right? So it maybe I left the house, I went to fill up with gas, then I went to the drop off the kids at school, and then I went to the grocery store, and then I came home. Okay, and I made a bunch of stops in between, but that doesn't matter. What I'm looking for is what is the total distance I covered and how long did it take me to do that entire trip. Okay, so that's a big important concept for you right there to keep track of. So kind of things, if you're keeping track of a little cheat sheet or a study sheet, that's something that you want to put on there. So for long answer problems, we've talked about communicating your work, but we'll chat about it again. You have to be able to implicitly communicate your work so that whoever is looking at it can follow it easily without having to, you know, look around the work trying to find where did this number come from and all of that. Variables have to be given, formulas have to be given. So you have to communicate the method. So the first thing, you have to list your knowns and your unknowns, right? Tell me what it is that the question is giving you. Write your formulas. That's the second thing. Write your formulas as they are shown on your formula sheet. And then you're going to substitute in numbers with the units. So that's nothing brand new for you guys. And then finally, you're going to give the solution with the correct number of significant digits and a statement. And so that's a complete long answer problem. So I've got an example for you here to calculate average speed. And it says, in a challenge, a student walks, let's add the S there, a student walks 200 meters around the school in 10 minutes. What is the average speed of the student? Express your answer in kilometers per hour. Okay, so they're giving us distance is 200 meters. It tells us that it takes 10 minutes. That's our only distance, so that is our total distance here and our total time. And we want to figure out what is the average. So we've listed our knowns and our unknowns. We're going to show our formula. V average is equal to our delta D over our delta T. We'll insert our values, 200 meters over 10 minutes with units. Okay, and now I want to, and we could do this one of two ways. So the first way I've shown you here is I'm going to do the unit analysis right away. So here's my 20 meters over 1 minute times, I know that there's in 1 kilometer, there are 1,000 minutes. So, meters. So I'm going to put my meters on the bottom so that they cancel out with this meters from the 20 meters. Now I want to get rid of the minutes, and I know that there's 60 minutes in 1 hour. Okay, and so that gives me hours on the bottom, and it cancels out my minutes, and I get 1.2 kilometers per hour. So that's the first method. The second method would be in this spot here to calculate what is, oh no, never mind. That's what I did there. So we'll just continue on here. Okay, so I took 200 meters divided by 10 minutes. I found my answer. That's 20 meters per minute. And then I'm canceling out units to get to the unit they're asking me about. You do need to know that there's 1,000 meters in a kilometer, right? You do have to remember that. So there will be some unit analysis in this particular section. And then I look at significant figures. 10 was my smallest digit, so number of significant digits, so I will keep my answer as 1.2. And then finally, I put my little finishing statement. Therefore, the average of the students is, or the average speed of the students is 1.2 kilometers per hour. Okay, so that's the first question. Second question here, maybe slightly more difficult because there's a bit of rearranging that has to take place, is a ball rolls at 50 meters per second and travels a distance of 6.0 kilometers. How much time did it take? So they've given us the average. Average speed is 50 meters per second. The distance that the ball travels, the total distance is 6 kilometers, 6.0 kilometers. And we want our time. How long did it take? Now, notice that our speed has been given as meters per second, and our distance has been given in kilometers. So I'm going to change this distance to meters so that my units match. And I know that there's 1,000 meters in 1 kilometer, so 6 kilometers is the same as 6,000 meters. So I'm going to show my formula right off the bat, and I'm just going to walk you through this rearranging before we move on, just to make sure everyone's with us. So here's my formula. Okay, I need to isolate that t value. So in order for me to get rid of that t from where it is right now, I need to do the opposite operation. Right now, this t is being divided. So that means that I need to multiply both sides by t. Okay, and that means that these t's will cancel out. And I'm going to do this step by step. I don't need to see all the step by step when you guys are doing a long answer problem. You can just show me the rearranged value, and and that is completely fine. I'm just doing this right now so that in the notes section, excuse me, you guys are following along if you're not 100% sure how to rearrange your formula just yet. So this leaves me with delta t times V average is equal to delta D. Now, I need to isolate delta T, right? I want it by itself. Right now, it's being multiplied by V average. So if V average is being multiplied, I'm going to do the opposite operation. Right, so I'm going to divide by V average so that the V averages cancel out. And that leaves me with delta T is equal to delta D over V average. If you're a little iffy on rearranging formulas, it pays to spend a bit of time working through rearranging, because there's a lot of rearranging of formulas in this particular section. Okay. So there we've arrived at our rearranged formula. So that's essentially what was happening here. Like I said, I don't need to see all the little bits about rearranging. You can just go from V average equals delta D over delta T to delta T equals delta D over V average. And I'll know that you rearranged. I'm going to put in my my variables, my quantities, my 6,000 meters divided by 50 meters per second. The meters cancel out. And this gives me 1.2 times 10 to the 2 seconds, or 2 minutes. Okay, you don't have to, if the question doesn't tell you to switch to 2 minutes, you don't have to. In this case, I did, and I said, therefore, it takes 2 minutes. Okay, but again, my rule of thumb is if the question isn't specifically saying express your answer in minutes, then don't spend the time on it, because time is of the essence when you're in a test. Right? I believe this is my last question for you guys. An airplane travels 1,800 kilometers at a speed of 1,000 kilometers per hour. It then encounters a headwind that slows the plane to 850 kilometers per hour for the next 2,300 kilometers. What is the average speed? Okay, so the previous examples have been fairly simple. The first one definitely simple, because that was just plug numbers in and calculate. The second one's slightly more complex because you had to rearrange a formula. And this one is definitely more complex, because they're telling you that the plane travels a certain segment at a certain speed. And then something happens and it causes the plane to travel the next segment at a different speed, right? And so we've got two parts here. So in the first part, our first distance is 1,800 kilometers. So that's our D1. Our first speed is 1,000 kilometers per hour. So that's our V1. Our second segment, the distance, is 2,300 kilometers. And the speed for that second segment is 850 kilometers per hour. And we want to know what is the average speed for this particular trip. Okay, so what we need to figure out, if you notice, we've got D, we've got V, and we've got T. So we've got the startings of our V average is equal to delta D over delta T. So I need to figure out for this first segment, how long did it take this particular airplane to travel that 1,800 kilometers at that speed? So I've rearranged my formula. So delta T is equal to delta D over V1. I've got 1,800 kilometers per 1,000 kilometers per hour. And that gives me a time for this first segment of 1.8 hours. So this is all for my ones. Okay, that's how long it takes for this first segment. 1.8 hours. Now I need to figure out the same thing for the second segment. Well, I know that we traveled 2,300 kilometers. I know we did it in 850 kilometers per hour. I need to figure out how long did that take. So for my for my V2, these are all my 2's, I'm going to rearrange this so that I solve for t. I've got 2,300 kilometers divided by 850 kilometers per hour, and this gives me that T2 is 2.7 hours. So that second segment took me 2.7 hours. Now, to figure out my average speed, what I need is I need the total distance. So I need the distance 1 plus distance 2, and I need the total time, time 1 plus time 2. Right, so V average is delta D over delta T. Delta D is the same thing as saying distance 1 plus distance 2 and on and on and on and on over time 1 plus time 2 and on and on and on. In this case, my distance 1 was 1,800 kilometers plus my distance 2, which was 2,300 kilometers. My time 1 was my 1.8 hours, and my time 2 was my 2.7 hours. If I sum those two, the denominator and the numerator, and I divide, I get 910 kilometers per hour. That's the average speed that it took this particular airplane to travel that entire distance over that entire time. Okay, so that's definitely a little bit more complex compared to the other two, but very, very plausible for something you would see in a worksheet or a test question. So make sure that you're good with that. Okay, that's all I've got for you guys right now. Next time we meet, we'll be talking about average speed. So I hope you guys are well. Take care. Let me know any questions you have when you come into class, and we'll give this a go when we see each other. Bye for now.